Yeah, very good evening. Good afternoon as well. Hello, yeah. Okay, so how are you? Everybody is fine? Okay. Okay, so how are you, everybody? Nice, I'm fine. Okay, so today, let's go. Okay. So today we are going to do a classification. We are trying to understand the classifications now. So here, we all are aware with the machine learning. We are aware with its two categories as well, the supervised learning and the unsupervised learning. In supervised learning, we are aware that we have two categories, regression and classification. Okay, students, can you tell me one thing? Suppose my target variable is having a float data or continuous value. My target variable is just like 24.5, 68.3, 44.3. So in this case, which particular algo I should use if my target variable is continuous data? Thank you, and gave me a response in query portal. I'm asking if my a target variable is continuous value, so what should I use? My target variable, my y is continuous values, floating values. So what should I use it in this case? Think it. I'm giving you time to think. Exactly correct, Sandra. Farouk, right. Only few answers will get. Okay, so in this case, linear regression is required. We are going to use the linear regression whenever my target variable is continuous values or floating data. Think it, my y is into the form of true, false, true, false, false, true. In such cases, where should I go? What should I use? Which one? If my values are only true, false, or yes, no, that's all. What should I use? Exactly correct. Right answers. In this way, we can use a logistic regression whenever my outputs are yes, no, or true or false. Logistic. Exactly. Now come with a situation where my outputs are, my y are YR in a different format. My YR, think it in a different format. Suppose I say, I'm having certain weather data, and there I'm having a Y into the form of cold, hot, rainy day, or stormy. So you can see I'm having a different categories. Either it's a cold day, or I can say it's a chill or snowy day. I can say cold is just cold. I can say it is a snow day, also snowy day. Cold day, hot day, rainy day, stormy day, if I'm having a different types of categories. So in this case, I would be preferring the classification. So the point is that when we talk about the supervised learning, you are already aware there are further two categories, regression and coming to the classification. So in this case, when we come to the regression, linear regression is there and logistic regression is there. When we talk about the linear regression, I'm having all the values in decimal data, Y values. In logistic, my Y values are coming into the yes or no, only two values. Either it could be 0, 1, 0, 1, 0, 1, does not matter. But in case when I'm having a kind of data where I'm having different categories into the Y, those categories could be anything. Not only I'm talking about like a stormy day, snowy day, hot or sunny day, rainy day. Not only this. So if I'm writing a hot day, rainy day, I guess a storm, it's storm, or it's chill. Different categories I'm having. So in this case, I can go ahead with classification. Or even you can take any other categories, I'm talking about. It could be any category. Suppose there are different types of food ingredients and they are giving certain category of taste. There are several tastes into the foods. So suppose you can consider these are certain food tastes are there. Okay, just like sour, bitter. Okay. So it means these are different types of tastes. So they are coming into the different categories. So it means here we can use the classification. Here we can use the classification. Got the point? So here, in case of linear regression, whenever my output variables are into the continuous values, we can use the linear. Whenever my data are into the 0, 1, 0, 1s, yes, no, true, false, I can go ahead with the logistic. Whenever I'm having a multiple categories into my Y label, we can go ahead with classification. Now, when we talk about the classification, there are several algorithm associated inside the classification, such as naive Bayes. Naive Bayes is one of the algorithm. K-neighbors classifier. This is a tree. Support vector machine, support vector classifier, and other algorithms. There's so many algorithms are there. They all work in the depth of it, they all work with the mathematics. So let's go ahead and see how this algorithm works, how we can use it as a library into our own codes. So let's go ahead with the naive Bayes classifier. Okay. Now let's see how these classification algorithms are working. You can see here classification in Python. Classification is basically a two-step learning process, learning steps and prediction steps. In the learning step, the model is developed based on the given training data. Into the prediction step, the model is used to predict the response for given data. Here we have different types of classifiers. They are name bias classifier, decision tree classifier, nearest neighbor classifier, and support vector classifiers. So basically, when we talk about the naive Bayes classifier, it is a classifier, a machine learning model that is used to discriminate different objects based on the certain features. A naive Bayes classifier is a probabilistic machine learning model that is used for classification tasks. So here, basically, there's a person, his name is Bayes. His name is naive Bayes. He created one theorem. On that basis, naive Bayes classifier is created here. So this one is a Bayes theorem, which is working behind the naive Bayes classifier. So what I'll do, I'll be using it. Wait, I'll be taking one of the example and using everything here. These are all mathematics working here. Just let me take out the simplicity here. I'm going to take one data set and then I'm going to create here naive Bayes classifier. In case of naive Bayes classifier, basically what we do, we create a frequency table and probability table. So frequency table is created with each and every column. Similarly, we create the probability tables also with each and every column here. So when we talk about here, this particular naive Bayes classifier, so let's build a frequency table and let's see how these equations are working. Let's consider here one example. So suppose here we are having a data set. The data set, inside the data set, we are having 4 columns, which is showing some data, and based on to those input features, here there is one of the consideration, there is a player actually. The player means inside this data set, we are creating that based on to various conditions of whether the player is going out to play or not. Okay, whether the player is going out to play or not. So here player is taking the decision whether to go out or not based on the input features. So here we are having 4 columns basically, right? Here we are having 4 columns. The column names are outlook, temperature, humidity, and wind. These are the 4 columns. When we talk about the outlooks, there are 3 values inside the outlook, that is sunny, overcast, and rainy. Inside the temperature column, there is a hot, mild, and cool temperature. Inside the humidity, there is a high and normal temperature. Inside the wind, there is a weak and strong winds. So the point is here, these are the values. All these are the values, and these are the column. These are the column names. Now there is y variable, y. Inside the y, I'm having the values of yes and no. So here I'm taking a very simple example just to understand the naive Bayes classifier. Okay. Don't go with the only values of yes, no. The point is here, I'm just taking a frequency table based on the categories. Simplified categories here I'm making. So let's take a data set here. Let's try to understand how the frequency table we can create it, and be careful when I'm creating the frequency table here. You can see here that how many total number of rows are there. There are, see here, these number of days you can just see here, day 1, day 2, day 3, and these are 14 days data. Okay, inside this data set, 14 days data set is there. Fine. Outlook is one of the column, and the values are sunny, overcast, and rain. Temperature is another column. So hot, mild, and cool temperature are there. Humidity column is there. So high and normal humidity. And wind is there. So weak and strong winds are there. These all are X. So X1, X2, X3, X4 input data we are having. What is the output data? This one is a response. This one is the output data. This one is the output data. Inside the output data, response is the outcome variable. We are having a yes or no categories here. So here we are having certain categorical data. Okay. Now we have to take one thing here. See, we are preparing a learning phase. Learning phase means we are preparing the training phase. Okay. So here, we need to prepare a frequency table. This is a frequency table, and we need to understand how this frequency table is created, and be careful with this one here. Okay. Here you can see the frequency table is created and the probability table is created with each and every column I'm talking about. Okay. Now here we have to check that how many times a particular value occurred. Occurred means what is the frequency of a particular value inside any particular column, and then how many times the player has gone out to play or not with that particular value. Suppose here I'm taking an outlook. Outlook here I'm taking outlook. There are 3 values inside the outlook. That is sunny, overcast. Overcast means little cloudy, and rain. Rain is there. Now by taking it, we have to check how many times sunny happened, and inside the sunny weather, how many times the player has gone out to play or the player does not go out to play in different weather. The same I have to check with overcast. The same I have to check with rain also. Okay. So let's take it out. Suppose here I'm saying is sunny, sunny. 1, 2, 3, 4, 5. So 5 times sunny happened. Sunny weather was there. Now in sunny, when we are checking it out about the sunny. So here sunny, you see here what happened with sunny. If sunny is the input value, so what is the output value? No, no. So sunny, sunny, no, no. So 2 values with no. Any other no? No. Third no. So 3 no. Then yes, yes. So it means 3 no and 2 yes. 3 times the player has not gone out to play when sunny weather is there, and 2 times the player has gone out to play when sunny weather is there. This is a case of sunny. Now we have to build up a case for overcast. What happened to overcast? So how many time overcast happened? How many times the cloud, a little cloud was there? Overcast, 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 overcast. So it means 4 times overcast happened. Let's take it out. Overcast happened 4 times. Then what about the values of yes or no? Suppose overcast is there. So value of yes or no. So here let's see. 1, 2, 3, 4. This one. Oh, this is 3 or 4. This one. So 4 times yes has happened in overcast. So it means all 4 times the player has gone out to play. It means if the weather is overcast, means a little cloud is there. So there the player has gone out to play and 0 no is there. Of course, correct. Overcast 4 times and yes 4 times. Right. Yeah, right, Akash. Fine. Thank you. What about the rain? Rain. How many times rain occurred? 1, 2, 3, 4, 5. 5 times rain occurred. And how many times yes and no happened? So yes and no happened in rain here. 1, 2. 3. 3 times yes happened, so 2 times no happened. 5 times total yes happened. Wait, yes, let me check it out. In rain, I am talking about this is the rain here, na? So yes, rain, no, rain, yes. So 3 times yes happened, 2 times no happened. I'm correct here? 3 times yes and 2 times no in case of rain. Now it is right, na? So in this way. So the point, what I'm saying here, so see here, we had just figure it out, the frequency of sunny, overcast, rain in outlook column. And we had tried to find out yes or no, that how many times yes happened, how many times no happened. Okay. Now I'm coming down. So here, I need to build up a frequency table. So let's check it out, this frequency table. Okay. So I will be using the same data here. So this one is the frequency table. This one is the frequency table. So here you can see outlook is there. And when outlook is there, sunny, overcast, and rain values are there. And here you can see the player has gone out to play. Yes, the player has not gone out to play. So frequencies are built up. In sunny case, 2 times, yes, the player has gone out to play. 3 times, no, the player has not gone out to play. So see here, I'm just telling both of the things. In the case of overcast, when overcast happened, 4 times yes, the player has gone out to play, and 0 times no, the player has not gone out to play. In case of rain here, 3 times the player has gone out to play, and 2 times the player has not gone out to play. Okay. Fine. So sunny, 2 and 3, 4, 0 and 3, 2. So here 5, 4 and 3 and 2, 5. Okay. Now you can see here how many times yes happened, total. Total time yes happened in case of outlook is 2 plus 4 plus 3, that is 9. And how many times total no has happened here? And here you can see 5 times no has happened in this case. So the point is, total there are 14 days data we are having. So it means out of 14 days, 9 times yes happened and 5 times no happened. Okay. Now this is a frequency table is created. Now based on the frequency table, the probability table is created. Inside the probability table, you can see so you can see here, what is the probability? Suppose here, how many times yes happened in total? 9 times. How many times no happened? 5 times here. So when we're talking about the yes, so how many times yes happened? Means what is the probability of having yes when the outlook is sunny? What is the probability of having yes? That player will go out to play. It is yes when the outlook is sunny. So it means total yes are 9. And the sunny probability of yes is 2. So that's why it is 2 by 9. 2 by 9. 2 by 9. What is the probability of no in case of sunny? If sunny weather is there, so whether the player will go out to play or not. So that is 3 by 5, because total no is 5, then 3 by 5. So 3 by 5 is the probability of player not to go. Means here the player will not go out to play. 3 by 5 is the probability. Now, if you check it out, the overcast, suppose weather is overcast, what is the probability of yes going out to play? That is 4 by 9. And what is the probability of not going out to play? That is 0 by 5. So nothing. In case if raining is happening, if rain is there, so what is the probability of out to play, whether the player is going out? 3 by 9. And 2 by 5 is the probability the player will not go out to play in case of rain. Rain is there. Okay. Now you can see here in the same way, the way I had built up a frequency table and probability table, one needs to find it out with the help of temperature also. That what is the way, what is the different values of the temperature, what is the frequencies of it. So we need to go to the data set again. Temperature. And you need to find it out inside the temperature, how many times hot, mild, cool happens. So let's do. Okay. Fine. So let's see. Temperature. What are the values? Hot, mild, cool. What are the values you're saying? Wait, let me check it out. Wait here. 4 hot. So I'm just taking the data which students are giving to me. 4 cool, you are saying. 4 cool and 6 mild. Huh? Six mild. Okay. And let me check it out. What are the data? If you check it out, this hot, mild, and cool, what are the various data with the yes and no? So here, when we talk about the hot temperature, so yes and no. So I'm taking data, Akash, I'm just taking your data here. In hot, you are saying 2 yes And to know in cool, just wait. In cool, we are saying 3 yes and 1 no. In case of mild, 4 yes and 2 no. Okay. Fine. So this is the data. Okay. So this is the frequency we had took it. Now let's build up the frequency table here. So here you can see when temperature is hot, there are 3 values: hot, mild, and cool. When frequency is there, so play. Okay, how many times the player has gone out to play? When temperature is hot, so 2 times the player has gone out to play in hot temperature, and 2 times no, the player does not go out to play. So these are 2. In mild temperature, the player has gone out to play 4 times, and 2 times no, the player does not go out to play. In case of cool, 3 times the player has gone out to play, and 1 time the player has not gone out to play. Okay, so that is there. After that, let's check it out. This one is a frequency table, so let's build up the probability table here. When we are building up the probability table, so here you can see what is the probability of going out to play when hot temperature is there. So that is 2 by 9, because total time yes happened 9 times and total 5 no happens. So 2 by 9 is the probability when the temperature is hot, player will go out to play. What is the probability of no? So that is 2 by 5. So 2 by 5 is the probability that the player will not go out to play in case of hot temperature. What is the probability of mild case here? So that one is a 4 by 9. And here 2 by 5 is the probability the player will not go out to play. So here 3 by 9 and 1 by 5 here. So the point is here, these are the various probability the player will go out to play or not here. Okay, so these are there. The same is now you can find it out various frequency table and the probability table with the humidity. In humidity, you are having a high and normal value, so you can just find it out from the data set. So frequency table is created and the corresponding probability table is created. And now there is one more column here. You can see wind. Inside the wind, there is a strong wind. Okay. So here you can see we are having a wind. Inside the wind, we are having a strong and weak wind. And when we talk about the strong and weak wind here, these are the various frequencies of strong and weak wind. And here we are having the various probabilities, whether the player will go out to play in strong wind or not, whether the player will go out to play in weak wind or not. So these are various frequencies and the probabilities. These are the various frequencies and the probabilities are there. Okay. Now, so we created it. Now see here next. One has to find it out that how many times yes happened, how many times no happened in case of response variable. So this one is the outcome variable here. This one is there. So how many times yes happened or how many times no happened here? Like You can see here, yes and no values are there. So if you calculate these values, the total values, total days are 14. So 9 times yes is there. Yes, the player has gone out to play. And 5 times the player has not gone out to play out of 14 total number of days. Okay, so that is there. Fine. So this is the same data. The frequency table and the probability table is created with this data. Got the point here? 9 times yes happened, 5 times no happened. So 9 by 14 and 5 by 14 here. And 9 by 14, the probability is yes, and 5 by 14, the probability is yes. So this is the frequency table, and the probability table is created during the training phase of Naive Bayes classifier. Now here you think it out. Now there's the after this is a training place. So now here we are giving the prediction phase. You think it out. Suppose outlook is sunny. Suppose here let's take prediction data. Prediction data, it means we are giving the new instance of weather conditions. Think it out. Suppose the new prediction is during the prediction phase or testing phase here. Suppose outlook is sunny, temperature is cool, humidity is high, and wind is strong. These are the different weather conditions. So we have to predict whether the player will go out to play or not. Okay. So in this case here, we have to find it out all the probabilities of happening yes or happening no. It means we are having currently two response variables. Either the player is going out to play yes, or the player is not going out to play on different weather condition. So here we need to check it out, the given input weather condition, whether with these particular input condition, whether the player will go out to play or not here. So we need to take the probabilities of happening yes, probabilities of happening no. So let me take this data. So here we are having outlook sunny. Sunny, temperature cool, high, wind, storm. If this is there, so one needs to find out what is the probability of yes with all these four conditions. So here, suppose you can see here, when outlook is sunny, what is the probability of yes? And no also I need to capture. So outlook sunny, so what is the probability of going out to play? So in sunny weather, the probability of going out to play is 2 by 9. And the probability of no is 3 by 5 in case of sunny. Now let's go with the temperature. So here, see here. Suppose here temperature is there, temperature cool is there. So temperature cool is there. So what is the probability of going out to play? 3 by 9. And the temperature is there 1 by 5. Probability of getting humidity high humidity. So here play is equal to yes. So 3 by 9 is the probability in high humidity, and 4/5 is the probability of not going out to play in high humidity. What about the strong wind? So when we talk about the strong wind here, strong wind. So strong wind here, the probability of going out to play is 3/9 in strong wind, and the probability of not going out to play, that one is 3/5. So different probability in yes and no conditions are there. So let's take this now. In real time, it is not there. Directly, we are having the libraries to do this work here. So here you can see, we need to check it out, the probability of playing, whether the person will go out to play or not. So here, probability, see here, we have to take all the 4 cases here of yes. So probability of sunny, whether the player will go out to play or not, that is 2/9. So 2/9 multiplied by probability of cool temperature, and when cool temperature is there, the person will go out to play or not. So that is 3/9. Then 3/9 will be the humidity high. So when high humidity is there, whether the player will go out to play or not, 3/9 and 3/9. So here 2/9 into 3/9 into 3/9. Okay, and what is the total probability? So total probability of class, what is the total probability of class, whether the player will go out to play or not? So that is yes. So that is basically total we are having 14 days. So 9 times yes, the player has gone out to play, and 5 times the player has not gone out to play. So the total probability of yes is 9/14. So all these values are going to be multiplied. So here 2/9 multiplied 3/9 multiplied by 3/9 multiplied by 3/9 divided by multiplied by 9/14. So all these probabilities which we have taken through these values, they are being multiplied. And let's see what is the data coming here. That is 0.0053. So this one is the total probability of going out to play in these sunny, cool, high, and strong conditions, where the player will go out to play. Yes. So this is the probability 0.0053. Okay. Okay. Now, if I'm talking about the no case, whether the person will go out to play or not. So now let's take the not probability. The person will not go out to play in these 4 conditions: outlook sunny, cool temperature, high humidity, and strong wind. So here we have to take all the no cases. Okay. So here you can see that these are the no cases here, whether the player will not go out to play. What is the probability, total probability? So here we have to take that if sunny weather is there and the player is not going out to play, what is the probability? 3/5 multiplied by cool temperature and the player is not going out to play, that one is 1/5. High humidity is there and player is still not going out to play here, so multiply by 4.5 multiply by 3/5. Strong wind and the player is not going out to play, multiply by whether the player is not going out to play, what is the probability for 5/14. So all these values are multiplied and we are getting 0.0205. So what is this actually? So here we are getting the probability of yes going out to play, that one is 0.0053, and the probability of not going out to play, so that is 0.0205. So which one is greater? No is greater. So it means if no is greater, what does it mean? it means that if our input values are with outlook sunny, temperature cool, high humidity and strong wind, the player will not go out to play. The player will not go out to play. Okay? So this is the total probability. Okay. So this is about the naive Bayes classifier. So this is overall like we are having naive Bayes classifier, but the point is here, everything is actually here. We are having the libraries. Naive Bayes classifier library is there. And inside the naive Bayes classifier, we are having two further libraries. It means there are two categories of naive Bayes classifier. First is multinomial NB, second one is a Gaussian NB. Multinomial NB will be working for more than two categories. If my Y is having more than two categories, I can go ahead with multinomial NB. But Gaussian NB will be working with only two categories, A and B. Only binary data for binary outputs, your Gaussian NB is working, and multinomial NB is working with more than two categories. So we are having we are having a library for it. So here I'm going to use those libraries basically. Okay. So yeah, exactly. Cricket analysis are being done on to this one. Exactly. So the point is here, you can see that how inside the naive Bayes classifier, we have a frequency table and probability table. So remember, basically in, I say in, in entire data, machine learning, in data science, machine learning, maths is working. And on the top of mathematics, libraries are built up and those libraries we are having. Is it okay? So here, now let's go ahead with a library now. So inside, you can see inside scikit-learn, if you type here, wait here, scikit-learn, you can just write here naive Bayes. So naive Bayes library is there. Okay. And here you can see naive Bayes method are set of supervised learning algorithm based on applying Bayes theorem with a naive assumption of conditional independence between every pair of features and the class variables. And these all are complete mathematics is there. Okay. So here we are having a multinomial NB. This one is a multinomial naive Bayes, which works onto the frequency table and the probability table entirely. So this one is a class here, class sklearn.naive Bayes multinomial NB. I can take it. Okay. And there's one more here. Gaussian NB, major one, major one. So there is a class sklearn.naive Bayes and the Gaussian NB is there. I can be using this all Gaussian NB. Okay. So let's go ahead now with this one and let's write the code for this. So if I want to work with it, so we'll be taking it here. Okay, just wait here. Here, I'm going to take one of the data set, iris data set, I'm going to take it. So inside the iris data set, you are already aware, there are three categories inside the iris data set. Means here there are four features, four input features and three outputs are there. There are three categories of iris data set. This flower is having three further categories. There are three species of this flower, that is Iris setosa, Iris versicolor, and Iris virginica. These are three flowers are there. Okay, so we can use it. So I'm having three categories, four input features, petal length, petal width, sepal width. And three features I'm having, three species, three class, three outputs I'm having, Iris setosa, versicolor, and virginica, that I'm going to take it. So now what I do here, I'm going to take this quote now. Library is calling, I'm going to do directly here. So, okay. So here I'm going to write it. Just wait here. So classification, I'm going to do it here. So here you can just write. So nearby as classifier here, I'm going to take it. Okay. So here I'm going to import certain file. sklearn it is. It is sklearn. Scikit-learn. Now I have to import this library now. This library. Okay, so wait here, just wait here. Okay, wait, import multiple language. It is train test that I have to take. I need to take the matrix. Okay, student here. Matrix when I'm talking about now. So here from sklearn.matrix import, same matrix I need to take. Earlier one I had took the matrix for logistic regression, same is here, accuracy score. Confusion matrix, classification report, all these things we need to take it. Okay, same it is. Multinomial, this one. Okay, I need to import the data set also. There's a load iris data set it is. I can load it. Okay. Or directly iris.csv file also I can take it. So let me check it out, please. Okay, it is just taking it. Okay. Okay, now it is loaded here. So here I am taking iris data set, and here I'm just loading iris data set. So once I'll be loading the iris data set here, this iris ds variable will become a dictionary. This one's a dictionary here, data, target, description, feature names, everything it is giving it here. Iris.data set. So see here, this one is a data set. It is just showing you 4 input variables. So 4 input variables are these one. One is petal length, petal width, sepal length, and sepal width. So here 4 input variables are there. So I can just check it out. Target also, let me check it out the target. So here I can say zero, 1, 2. So target is 0, 1, 2. 0, 1, 2 means here iris setosa versicolor virginica. Setosa versicolor virginica. These are the feature names here. Sepal length, sepal width, petal length, and petal width. So I can take them here. I can take them here, wait, iris data. Now here I'm loading this iris data inside the data frame. So df is equal to df iris, you can write it. Df is equal to, here I can write pd dot, it is a capital letter. Here I can give okay. So all the 4 column I can see it here. Sepal length, sepal width, petal length, and petal width. Everything we can see it here. Fine. Now I need Y. Y means either it's a class or species. I'm having class or species. That is, I can say 0, 1, 2. 3 categories are there, which is belonging to Irisitosa versicolor virginica. These are here now. So here you can call, as I told, 3 categories are there. So 0 is Sitosa, Irisitosa. 1 is, you can say that one is Iris versicolor. 2 is Iris virginica. 3 categories are there. Sitosa versicolor virginica. This is there now. So DF is there. Got the point? So this is a DF. Now I need target variable also. So what I'll do here, I can take a target, or you can call it a species, you can call it a class, or you can call it a species. Anything you can call it. So you can give it a class, that what type of class it is, you can call it. So here, we can give here this particular target, this particular target as a class. You can call it a class, you can call it a call it a target also. See here, I written a class now. So the class, because I had given a name here, class, so class is there, class is there. Now here you can say class is what? 0, 1, and 2. You can say 0, 1, and 2. 0, 1, and 2 are there. $150 rows and 5 columns. So this is the class, okay, and 4 columns. So you can, it means you can well understand now. These are what? These are x1, x2, x3, x4, and this one is a y. Okay, so that is there. Wait. Now come. So now we can see df dot head. So these are the df dot head. So complete area, you can have it. Tail, so top, bottom 5 rows, it is going to show you df dot sample here. It is going to show you df dot info. All the information it is showing you that 4 inputs are there and the class is there with 150 rows here. Data type, everything it is going to give to you into the info. df.t types here it will be showing you what are the various data types here. You can find out df dot is null dot sum. Find out is there any data with a null or sum. There's no missing data. Otherwise, one needs to create it here. Then you can do a lot here, df.com. There's a lot of things you can just find it out. Into the heat map, you can find it out. All this like so it means here, means one can do here R&D, one can do it here, ETA, you can do it here, df dot describe here. So entire things you will be taking slowly. Okay, everything you need to make the observations here, everything you need to do it here, entire EDA process. Now here, basically I'm having when DF completely, so I need to bifurcate it. Basically, I need to bifurcate the data into the training and testing here. So here, if this is a X data here, so I want to take X part here, so DF dot ilog, and I can take all the rows starting from 0 to -1. So -1 will be eliminated. My target will be eliminated. This would be X. And into the Y, I can take df dot ilog, take all the rows here and -1. -1 will be the class here. X is equal to df dot ilog colon. Here I'm going to give it, and here 0 to -1. I'm going to take it as the X. Into the X here it is. So I'm taking the input data, only X data here. I'm going to take it. All the 4 inputs are there. Coming to Y, so here I'm taking df dot ilog colon here 0 to no, only -1. I'm going to take it here. Here this is there. I'm having the target. Okay. Now here after it, I need to make the train test split here. Okay, so the X and Y I had extracted here. Class I had extracted here. Now I need to make the train test split. So here I'm going to make X train, X test, Y train, Y test, train, test, split. And here I'm going to give X and Y test size is equal to 0.3 also, means 30%, and random state I can give it. Random state is equal to 42, 43, anything you can give it here. Done. Data is done. Then you can give it here. X train dot shape, you can just check it out. 150 total rows, so 105 has gone towards the X train, X test dot shape, Y train dot shape, Y test. dot shape. Okay. So this is there. Now I will be applying the data here. So here when I'm applying the data, so that one is which one? I need to make the instance of it. Which one? Multinomial NP. So this instance I'm going to make it here. So M and B is equal to multinomial NP. I'm just creating it here. So instance I had created M and B dot fade, and here I can just give X train and Y train. So training is done, and now here I can take it, predict M and B is equal to M and B dot predict method. This is a variable, any variable. Predict method, I'm going to use it, and here I'm going to pass X test data. And here predict M and B, it is going to show you as an answer. Got the point here? Training, I did it. Testing, I did it. Now I'm going to use the matrix. In the meantime, what you do, just wait here. You read this code. You wait here. I'm going to make this all output clear. Clear from here. I just wait here. You just read the up to here, na? Read this code carefully. Take your time. I'm giving you 3 minutes, 3 or 4 minutes just to read this code. Then I'll proceed further. Take your time, 3 to 4 minutes, and read the code carefully. Now here, after that, what I can do, I can so here, these are different values I took it. Okay. Now here, X train, X test, Y train, and Y test are what? These are the bifurcation I did it. Okay, I had just bifurcated this data here. X and Y are bifurcated as a X train, Y train, X test, Y test. So these data are, we are passing it here. Okay, so that is there, fine. Now here I need to use what? I need to call now I need to call matrix here. Okay, sklearn.matrix I had already called there. So here I can say X test is the predicted output. X test is the predictions input, and Y test is the actual output. Okay. Okay. Now here I can just give here print. I'm just taking the matrix, how well the model is working, accuracy, score, and here I can give I can give here predicted output and Y test. Y test. This is not a prediction. This is a predict M and B. .95 means 95%. So basically here 95% correct rate is working. 95% your accuracy is coming, that is good. Confusion matrix, it is going to give it. Here I can take a classification. This was the classification. So you can see here, like, see how we can understand the confusion matrix now. This one is there now. So this is the actual output. Wait. This one is the predicted output, and this one is the actual output. So the values which are coming in this zone, they are the diagonal value, they are the correct values. What are the values here? 19, 12, 12. Okay, 19, 12, 12. And here you are having values of 1 and 1. So 1 and 1. Got the point? So here it is 0, 0, 0, 0. So actually, you can see all the values are coming here into the diagonal. They are the right values. 90 rows or 19 cases are predicted as Setosa species or Setosa flower. 12 rows or cases are predicted as versicolor flower. That is a versicolor species, and 12 cases are find it out as Virginica flower, Virginica species. So these are there. Now you can see accuracy is 0.95. So when accuracy is 0.95, it means some of the data are moving into the, some of the data are going towards the error also, just like a 1 and 1. Okay, means 1 rows are predicted wrongly also. Doubtful cases, we can say. Okay. So that's why if any of the data is coming apart from this diagonal, either here or here, so these data are basically error zone. So if the data are moving into the error, or these are just doubtful cases. So that's why my accuracy is coming 0.95, means 95% correct identification is there. And in case, suppose here, this is there. Any data, if it is 0, let's consider if it is 0. So it means everything is right, means 19, 12, 12. No, 12 plus 1, 13, and 12 plus 1, 13. So it means 19, 13, and 13 are moving into the diagonal. So rest of the data are 0. If it happens, I'm talking about. So if this is the case here, if this happens, so it means all the values which are in diagonal, they are the correct diagnosed value. So in this case, your accuracy will be 1.0. But currently, some of the doubts are there, so that's why it is coming. Now here, if I talk about the classification report, so here it is saying the total number of rows we had sent, because see, 150 rows are in total. And when we bifurcate the data with to 80% training, 20% testing. So here, out of total 150 rows, so 45 rows move into the 20% part, testing part here. Okay, this one is the training. 105 rows will be coming into the training. So here, 45 rows they are sending for the testing purpose, out of which Setosa species, which is 0, is identified correctly, where 19 rows are belonging to Setosa. When we're checking out about versicolor brand here, versicolor. So here, 13 rows are in total we had sent, but correctly identified 12 here, and 1 is doubtful. It means 92% correctly identified. The same is happening with the Virginica. 13 are total and 90 means 92% correctly identified. 13 are total. Okay, so total average is 0.95. So 95% correctly identified. So the model performance is basically 95% correctly. Still, it's very good if you are achieving 95%. So this one is matrix. Matrix gives you the model performance, how well the model is working here. Yes. These are errors. Errors are type 1 error and type 2 errors. So simply here we call it errors. Even you do not go into the very depth type, which is one is a type 1 error, type 2 error, but here simply here these are errors. 1 here, these are, you need to focus on, like, there are errors. Simple. If this is the correct diagonal, and any value which is moving this side or this side or any of these sides, they are error or doubt zone, doubtful cases. Need not to identify like type 1, type 2. Technically they are a type 1, type 2, but it does not matter. If my all things are here now into this diagonal, so it means my automatically this confusion, this accuracy score will be up, this average will be up, everything will be 1.0, 1.0. But if here some of the doubt zones are there, if some values are here, some values are here, so they are the doubtful zones. So it means machine is somewhere like 92% correctly identifying versicular cases, 92% correctly identifying Virginica cases. Yeah. So this is overall for a naive Bayes classifier here. Okay, now wait. Now here, identification is there. Now what I can do, see, right now it is 95 now. So if, let me try about the random state. Random state is a seed value. This 42 is a seed value. Random state is a seed value which will be taking the different row numbers which are highly correlated with each other as testing rows. Rest they will be sending as the training rows. So here I can change it. Suppose here let me change it out over the 45. I'm just making a test here. Maybe I can come up with my accuracy score. Let me test here. Oh, it is coming down. 86 it is. Let me try 48. It is 86, 86 with accuracy, no. 50 or 51, let me try. Oh, it is going down, 82 as a accuracy. Suppose that I'm writing 41. So I can start to the value where I'm getting a highest one. 93 it is 93. Let me try here. One more. I will be sticking to that. But generally, 42 it always gives better. They say, by the way, it gives better. 93. Generally, these ranges are getting. So here, a test and trial we need to do actually. Here now it is. Means I had rotated all the values. So 95 is the highest one I'm getting. Okay. So in this way, I can just take it. Now let me make our predictions here. Okay. So here, wait here, let me make a prediction function here. Any value here, you can send it. one row, many columns. MNP is the instance name. Multinomial NP. Here I can just take this t value, updated t value. I have to build up a T. T means I have to build up a number array. And I can give any similar value. So what you can do, you can take a similar values from here. You can change the values as well. Does not matter. You can change any of the value, but similarity value you can give. The value pattern should be similar. Because you had trained with such type of values, the value pattern should be similar. You can change the values on your own. And now here, I need to call the same function. This function I need to call where I'm going to send the t value here. The rest of the reshaping, it will do it on its own. So here I'm calling predict MNB function. And this t value will be passed here as an argument. And now it would be reshaped and then it is going to predict t. Okay. And prediction output, it will be taking 0, 1, 2 and giving it the answer. So here, oh, it is saying this is the Sitosa class. Means here, this function is being called here. And here, this values, all these values, these are being passed as a t and t is coming here. Reshape and everything is working here. Sitosa class, it is saying. Suppose here, I'm going to change any other values. So you can change the values on your own. Random values, you can give it from here also. These are all input values. Any of the value you can give it. Any value. Because why I'm taking the similar value? Because these values are trained here. You cannot never give a large value. Means the value shape you have to give the similar way, which has been trained. Suppose let me take I'm making this one as a comment. I'm taking another t here. T is equal to np dot array, and here, let me take it. It is a Virginica. If the values are high, larger values, so here it is a Virginica. We're saying this is a Virginica class of iris flower. If these are the new values, these are the Virginica. Have you understood? At least you can raise hand that the process you are getting, that how the things are predicted, means understanding you are built up. Later on, you can do the similar things. So building up understanding is must. That how I'm giving how I'm training, how I'm testing, how I'm using the library, how I'm just making the predictions with the newer data. Any data you can pass on here into the prediction, any data, but the values could be a type. Decimal values could be similar because the similar part we had trained. Okay. Okay. Okay, fine. You can revise the video now, automatically you'll be understand. This is a MNB I'm talking about. Okay, this one is a multinomial NB. Multinomial NB I talked about. So the point is here basically, just wait. So basically here, this one is entire MNB. MNB means multinomial NB. In case of multinomial NB, you have to do a lot of EDA here. In case of MNB here, when we talk about the multinomial NB, this is the MNB case. Now let's talk about the GNB. GNB means Gaussian NB, where it is going to apply on two, means whenever my y data is a binary data, so there I can apply the Gaussian NB. So here, what I can do, I need to find out a file which I did last time. Okay. So just wait. Students, just wait here. I need to find out one of the file here which I created last time. Now, logistic regression, you remember? Let me just find it out, please. For momentarily, I just stop the share of the screen. You need to wait. Let me find it out here where it is. Wait. Okay. I find it out. So, like, if you remember, I had created one of the file logistic regression. In case of logistic regression, I just find it out the two values, whether the person is having a cancer or not. Okay, last time I created this file. So I'm just executing this file run all, and here I'm using a Gaussian NB. Why? Gaussian NB can be used in those places where my outputs are two, where my outputs are binary. Only yes, no, true, false, 0, 1. Just like in logistic, you used it now. 0, 1, only two binary outputs. So here we are going to take the similar. So I need to call Gaussian. Wait, yeah. Gaussian NB, I need to take it. Gaussian NB. So this I'm going to take it. Class sklearn.nearbias import Gaussian NB. This I'm going to take it. Here. So this one is the class. Wait here, which one? Cancer, if you remember, this one is the same class. I'm adding a code here. You can see it here. Okay, logistic regression, a class I had created, right? So I'd now updated it. I just click on run and run all so that my Jupyter notebook is ready and updated. And here I'm going to add some codes at the end of this file with Gaussian NB, a newer algorithm I'm putting it here. So this one is an older algorithm of logistic regression. This one line number 25. Now I'm going to take a Gaussian NB. So if I want to use a Gaussian NB here, I can, during the importing of library, I can load it. So here I'm loading it here. From, let me paste it from this class. I'm going to use it here from sklearn.nearbias import Gaussian NB. So this I'd added now. Okay, so here I'm going to use this Gaussian NB. I'm going to make the instance of Gaussian NB at the end, because one logistic regression I had already used. I'm taking another one now. I'm using the Gaussian NB for the same data set. We can do that also. Is run. Oh, it is not executed. It is saying in top you had added now this Gaussian NB, but you are not executed. Run, click on run. Now it is executed. And now the same, I'm going to call it here, this one, run. So Gaussian NB is there. Now here, I need to pass same data here, X train and Y train. So here I'm going to use it, GNB dot weight, because training we are doing, wait here. I'm doing the training here, Y train. Okay, training is done. Now here I'm writing predict GNB variable. And here I can take it GNB, just wait, GNB dot predict. And here I can take X test. And here, okay, 0, 1, 0, 1, all these values are coming. These values 0, 1 is coming as a prediction of cancer, it is doing it. So now here I can use it. Accuracy score, you can print it here. Here I can take confusion matrix, and then these are must. Matrix are must to check out the model performance. So after every algorithm train, you have to do the matrix also. So accuracy score is 0.97, 97% correctly identification is it is doing. And these are the confusion matrix and this one. So 97 is an average model performance is there. F1 score is a model performance in overall. So it is just going to show you 0, 74. Basically, here, how we can understand, here it is just showing you total number of rows we had sent it out as the X test. That one is a 114, out of which the person who do not have a cancer, they are 40, and the person who are having a cancer, they are 74. But how well the model is identifying? So that one is like 96% correctly identify, the model has identified correctly the patients are with no cancer, 96%, and with the patient with yes cancer, 98%. Why? Because 40 cases are with no cancer, 71 cases are with yes cancer, are identified correctly, and 3 are in doubtful cases. 3 are in doubtful cases. So these are a certain error. That's why your accuracy is 97. If I say 0 here and 0 here and all things are coming here, so it means 1 will be coming there. So, but here currently the model is saying that some of the errors are there, means some are confusions basically. So it could be also there. Okay. So one more thing here we have to identify, Okay. Now here, you need to check that suppose here, I had used logistic. Okay, wait. See here. This one is a cancer data set. So here, when I had used logistic regression. So what is the accuracy score with LG? With logistic regression, my accuracy is coming 0.96. Okay, 96% it is coming. And let me check it out, the accuracy score with the Gaussian NB. Gaussian NB. That one is 0.97. Gaussian NB is 0.97. Okay, and LG is 0.96. So can you tell me which one is working better? Which algo is working better on cancer data set, logistic regression or GNB? Thank you. That one is a GNB. GNB is working best. GNB is working 97% correctly. LG is working, logistic regression working 96% correctly. So here GNB is working high. So here GNB is working high. Gaussian NB is working high onto the one data set here. See here, I'll tell you. Wait, student, wait. Actually, no. Logistic regression when we talk about the logistic regression checks out the binary value in two categories, 0 and 1. The same is with GNB also. Okay, both works with the binary outputs, LG or GNB. LG or GNB. MNB, multinomial NB, works on more than two categories. My Y should be more than two categories. Yes, Gaussian NB will be used for categorical variable, but the output should be binary, true or false. Correctly, yes. Yes. So in this way, we can work with this data set. Got the point here? So how to use the MNB, how to use the GNP? Is it clear now? Okay.